In this video, we will review the chain rule. The chain rule is when you have more than just x to a power. It's a very short derivative rule, but very difficult to recognize. So when you know you have more than just x to a power, say instead of just x to the fourth, you have x plus 1 to the fourth. You have to use this chain rule where you bring down the power, subtract 1 from the new power, but then you multiply by the derivative of the inside at the end. So product has a plus, quotient has a minus in it, and the chain rule has multiplication of the derivative of the inside at the end. So looking at one of the ways that it could look. Again, there are several ways for this one. So short rule, but tough to recognize. So say we have x squared minus 11x, and it's all raised to the 10th. Well, we would want to bring down that power and subtract 1 for the new power. When we do that, we're going to keep the original inside still there. So just like if you had x to the 10th, you'd say 10x to the 9th. But here we have 10, and then we keep that x squared minus 11x, and now that's raised to the 9. Last part about the chain rule is multiply by the derivative of the inside. So derivative of x squared is 2x, derivative of negative 11x is negative 11. So not a tough rule to do by any means. Not too much longer than just bringing down the power and subtracting 1 from the new power. What makes it trickier is trying to recognize it. So if we had, say, f of x equals 10 over x cubed plus 4x all raised to the 5th. I might be saying, what's this quotient rule doing in here? This is not a quotient rule, though. We don't have x's in both the top and the bottom. So we would actually just say that we need to rewrite this. We have 10 times x cubed plus 4x. And since it's raised to the 5th in the denominator, it's really a negative 5 power. So now we can use the chain rule. We have more than just x raised to, this time it's a negative power since we pulled it out of the denominator. So we're going to go ahead and take that derivative now. We have negative 5 times that 10 that was there. So we have negative 50. We're going to subtract 1 for the new power. So negative 5 minus 1 is negative 6. The original stays on that inside. And the last part of the chain rule is multiply by the derivative of the inside. So derivative of x cubed is 3x squared. Derivative of 4x is 4. So bring down the power, subtract 1 for the new power, multiply by the derivative of the inside. So it might be x to a positive power. If it's a fraction, it's x to a negative power. And then another way that it can look is if we have x to a fractional power. So say you have the third root of the natural log of x plus e to the x. You have something besides just x to a power. And this time it doesn't really look like a power because it's under a root. So our first step is to rewrite it. So the square root would be the 1/2 power. The third root is a 1/3 power. If it's a fourth root, it's a 1/4 power. Fifth root is a 1/5 power. This one happens to be a third root, so it's going to be the 1/3 power. And now we're ready to follow that same chain rule. So we're going to write it as g prime of x, bring down the power, 1/3, and subtract 1 for the new power. 1/3 minus 1 is negative 2/3. We put that original on the inside and multiply by the derivative of the inside at the end. Derivative of the natural log of x is 1 over x, plus the derivative of e to the x is e to the x. So there's 3 examples of the chain rule. There are more chain rule videos on my channel, but ultimately bring down that power, subtract 1 from the new power, multiply by the derivative of the inside at the end, whether it looks like it's to a positive power, a negative power, or a fractional power. Lots of ways it can look, but they're all the same rule. More than x to a power, use the chain rule for derivatives.